There we go. Okay. Oh, gotta turn this thing on.
I showed the guy sitting next to me in the classroom the shutdown command earlier.
I figured it out after we talked about it. I don't, I'm not sure. It never happened again, so I don't know. But I ran one on a different machine just to see. The only thing is the one that ran on mine must have had a custom message, and I never figure out how to do that. But
Don't go to,
okay.
or if you go to the if you use the switch I, the shutdown switch I, it'll bring it to do.
I did get it to do the 60 seconds thing, and then I was scrambling. How do I kill the command? And I didn't catch it quick enough, and I had rebooted. But
just switch A for a board.
Okay, so today we're going to finish chapter 9 because we didn't quite make it. Chapter 9's databases. So last time, I mean, 2 people knew everything because they were in databases, and then, so I mean, for you guys, it's new. You should watch back through that and read the chapter. But I mean,
I just want to hear your guys' banter when I wasn't here.
No, there wasn't any.
I was going to say, every time I go back and watch it, it's just like all of us cracking jokes in the background the whole time.
I don't think there was any of that last week.
Because I wasn't here.
It was we had so few people, it was pretty tame. So I sent out an email just right before I walked over here. So get out of my face. Logistics for the next week and a half, or next week. So the exam's Tuesday. So it's like our only exam. It's over the whole book, but of course, like what we talked about in class. So what's in the slides. The book is a good, add some more details into some of that. Homework 3, which is I'll put out probably by 6 o'clock tonight, will be due right before the test. Because I thought I was going to make it due later, but then I'm like, well, you kind of want to have done it before the test. So that's a quick turnaround time, but it won't be super long.
2 questions.
No, but it'll be book questions, kind of selected from the chapters. The exam will be some multiple choice, some short answer. It can't be too many multiple choice because it's going to be open book and open everything. So, I mean,
don't throw the curve, Damon.
You can kind of look those up. So, the beginning of class on Tuesday, I will talk briefly about whatever for chapter 10 we don't get through today. I'll screen share this now before I forget.
Aaron said he posted questions for you last time and you missed them.
I saw them. I just didn't know what you do with them. Yeah, no, I eventually saw them. They popped up, but no one's on right now. So, what was I saying? Oh, the beginning of class, I'll talk about the rest of chapter 10, then the exam. I'll give you the last hour in class. If you really don't want to come, it's going to be available from 12 a.m. to midnight that day. I'd like it if you come so I don't have to just record. That would be the worst case, is no one shows up and I have to come in here and record a whole lecture of me talking to nobody. I've done that before and it's awful. Not because no one showed up, just because I was like pre-recording.
Make it even better if you were doing that and someone walked in and didn't know you were doing that and they just looked at you like you're freaking nuts.
Wow,
like,
you're weird. Yeah. So that'll be 2. Yeah, I'm gonna take a nap in the back. Did I tell you guys that one of my students asked me if I smoked?
No.
He's like, did you smoke a lot when you were younger? They're like, your voice is so scratchy.
See, like I had a teacher in high school. His name was Hartwig. If someone asked him that, he would have just been like, "No, I didn't smoke cigarettes, just crack."
Yeah. I was like,
yeah.
Thursday, I want to talk a little bit about agile processes. There's actually an appendix in our book about it, but I'll probably talk more about other stuff. I'll use some of that, but we'll be into the project. So starting next week, I'll start having you do the various stages that I want you to do. I will have your project your homeworks and your feedback on your project by tomorrow at 6 o'clock. I have all afternoon, so I'll get through the rest of them. I've started, just haven't finished. So the study guide, I'm like half done. I'll finish it right after class. I tried to get it done before, but things kept popping up. But just to show you kind of what it's going to look like, it'll have just some bullet points of the things that I thought were the most important. And I didn't just go like copy and paste the chapter headings out of the textbook, though I thought about it. I looked at it, I was like, I could just copy and paste this. This is pretty much what we talked about. But then I was like, well, that's kind of cheap. So I actually have been going through the slides and the book and kind of picking out the highlights. So that'll be, I'll finish that and post the homework after class, a little bit after class. So let's jump into chapter 9 and see. I can't remember exactly where we left off, but we'll figure it out. Don't record. Okay, blah, blah, blah. Chapter 8, we're past that. Chapter 9. So we talked about relation. So relation, table, and entity. So entity is what we had on our ER diagram, right? The rectangles. When we convert that into a database, so we call that the conceptual design, the ER diagram. The logical design is the actual like table structure we're going to build into our database. So the entity from an ER becomes a relation in our database. Relation and table are the same thing. So it's almost like 3 words for the same thing. Primary key, so that was the identifier in the conceptual model. It just becomes the primary key. That's the unique identifier for every row of our table. Functional dependency, this is the idea that a column or attribute, so column and attribute are the same thing in our table, can be used to determine every other attribute in that row. So like your student ID number can determine your name, your address. Where you get into trouble is when you have other functional dependencies within that same row, and that's where normalization comes in place. Foreign key, so that is as we map our relationships, we have to have foreign keys to connect our tables together to model the relationships. Referential integrity, that's why we use this model, so that if I say that I work in a department in the table, that department has to actually exist. I can't delete that department without first unconnecting it from everyone that's in it. So it prevents you from having bad data. Field, so field, attribute, column are basically the same thing. The column in the table, so you use the table column, table row column. If you're talking in database terms, you use relation, field. It's just equivalent words. Data type, so data type is for each of your attributes. It has a type. Is it an integer? Is it a string, which is a varchar usually? Is it a date? Which helps with referential integrity, because if I say that something's a number and something goes wrong in my code, I can't insert text into it. It'll only take a number. Null value, so null value is not the same as an empty value or a space. Null means there's nothing there. So null can be useful. It can also be dangerous because you don't know what it means. Does it mean that's unknown? Does it mean they don't have it? Does it mean it's missing data? You're never quite sure. The example we talked about last time was if a table had your student ID number and your social security number, a foreign student doesn't have a social security number. That would need to be null. But just looking at the table, you wouldn't know, are they a foreign student or did we not put their social security number in? You wouldn't know the difference. Maybe if you looked at their name, you could guess, but you're still guessing, right?
Why do you ever bring race into this?
My middle name's Hassan. You got a problem with that?
Yeah, we do.
Cool.
You guys have seen that Seinfeld where he gets connected with this woman named like Julia Chen or something, and he shows up and he thinks she's gonna be Asian, but she's not. She's like blonde, like, but everywhere she goes, she says her full name. So they're like accusing her of acting like she's Asian. You guys don't remember that one? I think I've been watching all the Seinfeld episodes on Hulu, and there's a handful of them in there, and I've gone through and watched the whole series several times, but there's a handful that I come across, and I'm like, I've maybe seen that once or twice. I think they get pulled from syndication because they're like a little on the edge. So I think that might be one of them because it's kind of, it's a little bit, yeah, on the edge. So, I mean, I've watched most Seinfeld episodes like 10 times each, probably some of them more. So when I see one that I've seen like once, I'm like, wow, that's weird.
I just love how they pitched Seinfeld. Did you ever hear about that? It
To
was
show how
Yeah, yeah.
you might have something.
It's my favorite show. So denormalization is where, well, normalization, it kind of would have been useful that that's a term first. Normalization is going through and getting your database in the best format. That's the easiest way to say it without going down a whole rabbit hole. But sometimes you take a step back and you say, okay, yes, database standards, that this is how it should be done, but practical standards, it doesn't make sense. The classic example is that if you make a table and you store someone's address and their zip code and their city state, technically, if you normalize that,
You just need the zip code. And get the
well, that's a kind of a different issue, but you shouldn't store the zip codes because there's duplicates. Like if you follow the normalization, that should be broken out into a different table. Same with like states and stuff. That's just a pain though. Like you don't really want it broken down that far. We're kind of in the file organization. That's where we'll go through every one of those. We stopped in the late 20s,
late 20s.
early 30s. It came up in class today that I'm 34, and my students were like, I thought you were like 25. I'm like, no, I guess that's good. Oh, it's because I was talking about
That's when you just whip
the
around.
World Wide Web didn't exist till 1991, and when I first had internet access, you didn't have World Wide Web access.
This is what you just whip around and be like, this is what happens when you smoke.
No, we won't go across that.
We talked about the synonyms and homonyms. So this is where we were talking about how do you actually store database, which usually we use a database management system and we just specify the data types and we let it figure out the details. The book goes a little bit into if you were to make all those details or make all those decisions about details. We talked about that, and I did like some of this information. So I guess right here we don't have very much. Well, actually, that's a decent amount. Okay, so record. So the physical table is the rows and columns that specify the fields. So the fields, the attributes within there. So we did talk about this. The idea is that you want to make it so that it doesn't waste a lot of space. This gets into the real low level, like when you're dealing with sectors and the logical units of a hard drive. If you store everything in a size that takes just a little more than a whole sector, it has to reserve the rest of that sector, and it's a waste of space. Am I saying it, Tom? You probably know more about this than me, but so the ideal is that those units are equal to the units you're storing because you're not wasting. I mean, you can get a lot of wasted space if you do that. So the physical length of the table row ideally fits within that storage unit. we want to be able to process the data. So if you're going to store data on a hard drive, it's best if data you're going to read together is stored sequentially because it's quicker. Now, I don't know with SSDs if that is as much of an issue. I think they're still thinking of hard drives. Is it as
Same issues.
same issues even with SSDs? Okay. So, and this is where denormalization really comes in, because if I split all these apart into these units and then store them, they're going to be all spaced apart on data storage. Whereas if they're all in one row, they have a better chance of being sequential. So this is like where defragmenting comes into play, which you don't really have to worry about anymore. But
I still do, right?
And don't do it to an SSD drive.
yeah, don't do it to an SSD though. But I do it manually too. But it used to make a huge difference. Like you did it, and you're like, yeah, my computer's like twice as fast, and now it's pretty minor. But so this is kind of that same idea, but in terms of a design of your database idea. Now, again, you hope the DBMS does a good job of all these things. So when you denormalize, you're recombining relations together to make it easier. So that's going to make reading quicker. It's probably going to make writes quicker. So where you might use denormalization, two entities with a one-to-one relationship. So if you have a one-to-one, you need to really carefully think, would it make sense just to bring these together? A many-to-many or a many-to-one, we can't, right? I mean, there's really nothing you can do. But when you have a one-to-one, maybe if you bring them together, you get some redundancies. Example would be like some of the address stuff. You're going to have some redundant data, increased storage usage of space, but there's a better chance those are going to be written sequentially. And from a programming standpoint, writing your queries becomes easier too. You don't have to do joins then, right? So
Join on, join.
many-to-many relationship with non-key attributes. So they're talking about if there's certain attributes in that relationship that aren't part of the key, kind of evaluating whether those need to be separately stored or not. Reference data. Oh, I read this in the book and I can't remember what this was actually referring to. I was ready to talk about this Tuesday, but so here's a couple examples. So the normalized relation, customer ID, name, region, annual sales. They're denormalizing this into A customer, P customer, S customer. This is like almost a reverse example. So they're splitting out the Atlantic, the Pacific, and the South into their own entities. So, I mean, this is a little, there's kind of two directions you can go with it. Here we're making more tables, right? But the idea is that you're putting these where if I want to retrieve, give me everyone from the South, they're together, right? So it's potentially quicker. Here's a many-to-many. Wait, no. Oh, it's because it's split into two. A is a one-to-one, B is a many-to-many, C is reference data. Okay, this is confusing how I split it up. So here's an example where we have a student. They have an application ID because they applied to be a student. This application table has that ID and then the rest of the data about it. And then it actually has a foreign key back. So this is one of those weird cases where they have a double foreign key, where I said last time, I'm not sure how useful that is. Here again, I'm not really sure how useful this is. But this is a one-to-one. A student only applies once, right? So the denormalized relation, they're just pulling in and making one student relation that has all of that information blobbed together. And then they're just saying you can do application date and qualifications could be nullable if that data is not available yet. So, I mean, there's a couple advantages here. One, we don't have like application ID stored twice. We don't have student ID stored twice. So there is a space savings there. And then two, from a programming query standpoint, it's a little easier, and it in some ways makes more sense. Here's a many to many relationship. So we've got our associative table here. What's that?
It's not many to many. Look at
Oh, it's a many to one, right? Many, one to many. Is this diagram just wrong?
Could be.
I think this diagram is just wrong. There's supposed to be a crow's foot, right?
No, it'd be.
Oh no, there's a.
But then not on the other side, so it's not a many to many.
Yeah, this is a weird diagram.
Many to one is many.
To one to many.
Yeah, one to many,
To one. To
one to many. One vendor has many price quotes, a price quote. I think this actually is right. One vendor will do many price quotes. A price quote, one price quote will have many items. This is a funky, they call it a many to many, but it's really because a vendor to item would be many to many. It's just a weird, we didn't really I don't really like designs like that, but. So the idea here is that they're combining item and quote together and saying you just have a vendor ID and item ID, the description and the price. So then you have a vendor, it would be a vendor has many quotes. It'd be a one to many. I don't know. I mean, we're collapsing tables together. The book here is talking about it mostly as like, then they're going to be stored together and more of the physical side of it. We didn't talk as much about that in databases. We talked more about, I usually think of it from the programming side. Now that's because I created the database and then I had to write all the code to interact with it. So, I mean, I kind of had that fuller perspective. So here is the reference data. So we have a storage, instructions, and an item. So the storage instruction says where to store and what type of container. So I guess it would be like, I don't know, a certain chip has to be stored in a certain temperature controlled room in a certain type of container. And then here's the item. And then here they're just saying, well, why don't you just put that together? The idea is from a fully normalized standpoint, more than one type of item is going to have the same storage instructions. So you might have two different types of RAM that have the exact same storage instructions. So this is a fully normalized, better design, but is it really necessary? Like, that's kind of the question with denormalization. You could just store the item ID, what it is, and then where you store it in the container. The disadvantage of this, if container types change, if I want to rename a container type, I'm going to have to come in here and rename all of them rather than just renaming it in one place. So there is a trade-off when you denormalize. So arranging table rows, and again, we're talking about the physical kind of layer of this. So physical file basically is just we have table rows in a contiguous, consecutive section of memory. Depending on the storage system you're using, you might have that each table is a file, or the whole database may be one file. Depends on the DBMS. I'm pretty much have done all my work in SQL Server and MySQL, and it's just one file. It has its own internal structure, and it just gets bigger and bigger and bigger. I'm not sure about which database systems would do the separate files. I think that's kind of dangerous. Seems like you could get in some real messes with that. What if you delete one of them?
Access is all.
Mm-hmm.
Access is all one, yeah. So not really sure. A file organization. So how do we arrange the records of a file? So you have that either one file for a table or one big file for the database. How is it organized inside there? And again, the DBMS is really ultimately taking care of this, but basically you have a couple choices. Do you want to retrieve data fast? Higher throughput for processing transactions. So you do want, I mean, that's really close to retrieval, right? But do you want to be able to get a lot of data quick as opposed to being able to get a small piece super fast? And then the last is the efficient use of storage space. So you can't really get all. If you want faster data retrieval, you're not going to get as efficient use of storage space. Now, in today's day and age, I mean, storage space is, I mean, it's not really an issue. So I would probably lean towards the faster. Well, I guess we have some other factors here. Protection from failures, it's the same thing. You can get very good protection from failures, but it's going to take 4 times more storage space. If you do a RAID setup and you have tons of redundancy, it's going to, might be faster too, depending how you do it, but yeah. Minimizing need for reorganization, and this is all leading into indexing, which we did talk about last semester, and the trade-offs. Like, if I build up a ton of indexes for everything, I can get data fast, but it's taking more storage space. And then when I insert, update, or delete, I have to reorganize all those files because they have to be sorted. I have to have a sorted index. So accommodating growth, this is a kind of a strange thing about when you deal with databases, but you set a size on it, and basically once you can just fill it till it gets full, and then usually you kind of have to double the size of it. It doesn't just incrementally grow. So like with our software company, I'd have to watch our database as we got bigger, and then I'd have to purchase for $5 more a month to add in 100 megabyte chunks to it. But there's a resizing process that the structure uses, like kind of like dealing with arrays in programming. Usually when you hit the capacity of the array, what do? You make an array twice as big, and then you copy from the first array into the second array, and then you just kind of do it again. It's similar to that. So, and the database file and the storage space you use, even if I delete a whole bunch of data, because ours would grow, and then I would delete all of the logs because I kept a ton of log. Technically, I've deleted a ton of the space, but that file doesn't shrink back down. You can run a shrink command on it to regain that space, but there's some potential. They really recommend against doing that when you can help it. So usually I would just delete it down to let it kind of, it's like almost like a dual layer balloon, but the inner balloon would shrink, but the outer would stay the same, and then that would fill until I'd have to expand that outer balloon. Just kind of a structure of how these work. Security, that's always an issue, but so ways we can organize the file, sequential. So that's just, you take them by key and they're stored one by one by one. This is exactly, I brought it up last time and last semester, retrieving the things that I didn't specify the order by, and they always came ordered by the key, and then one day they didn't. Well, the database system decided there was a better way to store those than sequential. But of course it doesn't tell me, so it was a lesson learned. If you want something to come back in a certain order, you have to tell it to come back in that order. If you do a sequential and you change one in the middle or you add one, it may require rewriting the file. Deletes are usually a problem here too, because if I delete 10 in the middle of a sequential thing, how do I regain that space in the middle? So that's where this comes into play. So that's wasted space. So that's why you don't gain it back unless you run that shrink command, which can go through and move everything around to regain those empty spaces. index storage. So this is, the rows are stored sequentially or non-sequentially, but a second index is created that points to the individual rows. So you can index, every primary key automatically has an index. You can index other fields. And, you know, I'm pretty experienced database-wise. I'm always afraid to index too much because there's so many trade-offs. I did index some things in orbital shift because we'd be searching for events by the start time and end time, and those weren't key fields, and the only way I could get them fast enough was to do an index. So you can have multiple indexes, but the trade-off is you make a modification, all those indexes have to be completely rebuilt. So inserts, updates, and deletes become much slower. So you have to say, do I want to be able to retrieve fast? Is that of highest priority? So the index is basically just a table that points you to that row, and the index is going to be organized like the index for start time of a schedule event is ordered by the start time of the schedule event, as opposed to the data in the table is ordered by the primary key, which was just the event ID, which is just an auto incrementing field, has no relevance. So that table will have the schedule event ID, the start time, whatever fields you're indexing by, and then some pointer in memory to where that really exists. You can have secondary indexes too. So you can combine some fields. So you can say I'm indexing it on this, but build a secondary index because I also want to be able to retrieve these fields when I hit this index. So that's what we did with the start time. The index was built on the start time and the end time, actually. And then the secondary index was, well, I also want to be able to get the employee ID of who works that shift and these other fields. So here's just showing a sequential and an index storage. So A is sequential, and they're just showing them like it's alphabetical here. B is index. So here we have the key, and there's a hashing algorithm.
That one's C.
Oh, that one's C. B, sorry. B, we have a key. Yeah, that's hashing, duh, hashing algorithm. B, we have a key. The key points here. This points to the letter. I mean, you can see it's like really complicated, right? So aces, flyers, these are all individual spots. These letters point you to them. I mean, this is, I think, kind of a convoluted example. The example I gave of the start time pointing to where in the regular table the data is stored, that makes more sense to me. Hashing, have you guys talked about hash tables in any classes? It's a data structures topic, but the idea with hashing, and it's like how dictionaries work in Python or in any language that has a dictionary, but you have a key value pair, and it basically allows really fast retrieving. It's similar but different than indexing. I mean, it's a pretty complicated topic, so I don't want to go too into it, but when you want to look up something by a key, a hash table is the fastest way to do it. It's not at all fast if you're not looking it up by the key. It has to just see, it's like kind of randomly ordered, but there's a mapping of the key to where the rows are. If you want to search by something not in the key, it's a sequential search through every single item. So
Can't do a binary search.
you can only do a binary search on things that are sorted. So you can do a binary search on this. So a sequential can, and I sort of showed you guys last time that you can run a query and you can use the query analyzer to see what it actually did. It'll tell you, did it have to do a sequential search? It'll tell you what kind of search it was able to do as you join all your tables together. And then you can identify, well, it didn't do what I wanted here. Is there a way I can make that faster? But, and I brought this up a lot of times, I could sometimes just rearrange my query, but it was exactly the same. And that query plan would change and it would be way faster. So that there's like this voodoo magic that goes on in the DBMS that you can't always like predict or control. So choosing index. So the primary key is index. Like that's in any database management system. It's good to index foreign keys a lot of times. Index for non-key fields that are referenced in qualification, sorting, and grouping. So that's exactly where the start time of events. If I want to say, give me all the events for this week so I can display them on a calendar, it's super slow to retrieve those unless there's an index on those. So hashed file, I mean, this whole, I think I spent a whole week teaching about hash tables in data structures class when I taught it. So controls for files, so backups, periodic backups. You have transaction logs, so you can actually see every impact of the database every time it changed, which allows some rollback. Periodic backup is just take the whole database file or files and back it up somewhere else. A change log. So Rackspace, our host for the software company, had some kind of backup. I backed it up every night and copied it via FTP to our local server, so I had an off-site backup. That data, no matter what, the idea was I couldn't lose more than 24 hours of data. If I had ever lost 24 hours of data, I think I would have quit and never come back. But
They took care of that for you.
yeah, but they told me to leave instead, so it happened naturally. So data security techniques. So I don't want to go too much in this, but encryption. How do you manage user accounts? Ideally, users are never working directly with the data. They're working with some copy of the data. So that's the end of chapter 9. So now I can go on to chapter 10. So the whirlwind of 2.5 days of a whole semester class. So
You hear people talking about the new the S6 or whatever that has a removable battery. It's like, oh wow, a phone with
Yeah, I know,
a
it's-
battery. I'm like, wow, what are they gonna think of next? A phone that flips.
it's amazing that we have to be pumped about features that we used to have. Like, it kills me. This phone, it's a Moto X2. It doesn't have an SD card slot, a micro SD. So I run out of memory. I can't even install updates because it fills up, and I got to go delete all my photos that are backed up in the cloud. It's like I had an SD card on a phone, a long time ago on my.
Didn't even have anywhere close to that capacity.
Yeah, I'm on the HCC Incredible, and it had a replaceable battery, and I could carry 2 with me, and I don't know.
Yeah, but they can't charge you $100 more if they put an SD card.
I know.
Yeah.
You know?
The new Moto X Pure Edition has an
I'm
SD
gonna
card.
say I've got one. Yeah.
Yeah, so
That was one of the selling points of me buying it. Was I was like, it's got a bigger display, nicer display, good speakers, and it's got the SD.
I've got to hold on to this till December. This is my last contract phone of Verizon.
I just bought
so-
this one.
Yeah,
Yeah. $250 unlocked, off contract.
nice.
Actually works really well.
I'm so glad contracts are
Well,
gone
Verizon
now, but
Yeah, I know.
No.
yeah.
Edge program.
I think
You
this
just
is my
pay
last.
$25 a month forever.
I think
You can, yeah, they don't do those anymore though.
That's just,
There's no contract
the one
plans
thing I
anymore.
hate
next
about
year,
that.
I'm off contract on this one.
The one thing I hate about that plan with Verizon is since there's CDMA phones on Verizon, you pay for it outright. You pay all the money, and then you can't use it except on Verizon.
Right.
So you're buying a
Locked
phone
in.
that you're still locked to, even though you pay full price for it.
Subscription.
It's
Yeah.
so
Well, you
stupid.
can
Connect
make
your
model
phone
for
and
revenue.
open it.
In marketing class in business school, we spent a lot of time analyzing the dollars and cents of the whole subscription model of cell phones, and there's a very good reason why they did it that way.
Well, and I mean, it makes sense, yeah, for that reason. But like I said, you get a cell phone and you can't even just root the phone and everything because the chip itself only supports CDMA,
Right.
so it doesn't work on GSM. And so,
Why do you think they don't switch?
Yeah, exactly.
So all right, so chapter 10, it's basically like, okay, we've done all the designing, planning, we figured out how we're going to store the data, like how do we implement it, like in one chapter. So, but that's because there's an assumption that this is something you've learned elsewhere, I guess. So how do we code, test, and convert an information system into a tangible thing? How do we install it? Do we do a direct installation, a parallel, a single location, a phased installation? So we'll get into these, but there's some trade-offs, of course, as everything else. What are the deliverables and the support you would need to provide with that? More training. Oh, issues of providing support to end users. I could go on and on about that. So that's what ultimately, I mean, I did get the boot from the company at the very end, but that was because I had gone back to school because I was leaving anyway. And it was providing support to end users that ultimately pushed me over the edge to leaving the company that I created. So, system implementation failures. So what if things fail? And maintenance. So maintenance is a big topic. It is different now with cloud environments because maintenance basically is forever with a subscription-based model, right? As long as people are subscribing, you're maintaining. It used to be different when I sent off some software and it had an end of life, when we didn't maintain it and didn't support it. Now, I mean, that's been blurred. And then what are some of the costs of that maintenance? So one of these lovely slides with too much. So it actually looks pretty good up there. On here, it's like super small. So 7 major activities are performed during this implementation part of the cycle. So remember, software development life cycle. This is kind of the end piece of that. So coding, of course, testing, installation, which again, if you're doing cloud, is blurred. It's actually really nice because to install it, I basically say, oh, here's my FTP server. I drag some files over and it's done. There's also a lot of trade-offs for that. People freak out like, oh my God, like you changed the picture on your homepage. And like, we were so confused. It's like, that's marketing. Who cares? Like, but I mean, that's how users are. Like,
when Google first started changing,
yeah,
adding the pictures and stuff. For the first time I saw that, freaked me out.
Yep.
Oh, they've been hacked.
Documentation, which is every software developer's like one of their least favorite jobs. I think testing also, but which is why you hire people and pay them half as much to test if you're in a big software company. Like Microsoft, their testers don't work for Microsoft. They hire independent, separate companies to bring testers. My wife's cousin worked for Microsoft, but she didn't work for Microsoft. She worked in a Microsoft building testing Windows Media Center. I went and visited and got a tour of the facility, but got paid half as much as the real Microsoft employees. But she was testing, and
My wife just sit there and listen to WMA file all day.
yeah. So, well, she was actually like watching TV because it was when the media center you could record TV.
Like when that was on Vista.
Yeah, exactly. Training, support. So I mean, those 3 are pretty well intertwined: documentation, training, support, and then maintenance. So the purpose, which is like kind of obvious, but you've made all these system specifications. Now you need to make it. So, we will try to compress, even though our book was 9 chapters of specification and 1 chapter of making it, we'll try to compress the specifications into like a couple, 3 weeks maybe, and then have longer to do it. So document the work that has been done. The problem is the work never gets done, so when do you document it? But help for current and future users. So this is where the support and the training come in. So coding, I mean, this book is sort of targeted by, I mean, I hope you guys know what coding is, right? But like we've been saying, it's a business book, so I don't know. It's at a broad audience, I guess you'd say. So you take specifications and you make computer code. Wow. Testing. Oh, you test the code. So
You gotta make sure it works.
testing can be performed in parallel with coding. I sure as heck hope it is performed in parallel with coding, and you don't code the whole thing and then say, let's test it. Modern processes, you build unit tests into your code that test it automatically and forever every time you build your code. Now, you have to have time to do unit testing. I always said, boy, it'd be nice to write some unit tests, but I don't have time. So like our code never had unit testing and only had person testing, which luckily we eventually had interns, and that was mostly their job. Here, I made this, spent half a day trying to break it and tell me what's wrong with it, and then I'd fix it. So installation, so take out the old system, put in the new system. This is where I said, if you're installing in a new business, that's the best. Like a new restaurant, here's Orbital Shift, that's easy. Telling them, stop doing whatever you were doing before and do this, that's hard. Even if their old process is no good, it's still hard. So, I mean, we're kind of, these are quick. They're sort of.
Where'd you come up with the name? Or did somebody else?
Orbital Shift.
Yeah.
You know, we were originally Orbital Software was our like company name, and Orbital Shift was like our product. The first, it was supposed to be like our first product, but eventually we just changed the whole company. We could get Orbital Shift as a .com. Orbital Software, we could only get a .net. Someone else was sitting on orbitalsoftware.com forever, some person in the UK, and didn't want to give it up. So Orbital Shift, which is technically, if you Google it, it comes up. It's some scientific lunar phase thing. I never really understood. My business partner thought of it. I mean, it came from the orbital thing, and I don't know. It really is kind of one of those names that means nothing.
Just sounds cool.
And all of our clients just call it Orbital. You know, like if you talk to them, they would just always call it Orbital. And then the logo, you know, when it was Orbital Software, we started out, we had this circular kind of logo, but then my business partner cooked up that, like, make it look like tags. It's like, looks like HTML. The O looks, which actually worked out awesome because then we could make hats and shirts that just had that as the like letter. So we had awesome hats and shirts. So. I don't wear them anymore though. I burned them. I didn't really, but I don't
You
wear
had a
them.
boyfriend burning?
Yeah, exactly.
That's right.
So here's just a nice little table about deliverables. So surprise, surprise, when you do coding, you deliver code.
No way.
Here's a stupid question.
Oh.
You can answer. What we're doing in Java class is coding.
Mm-hmm.
Yeah, exactly.
And testing.
And testing, yeah. That
It was actually written for me, because I am a business student.
right.
Computers, yeah.
And I mean, no offense. I think, you know, I talk down sometimes about business and stuff, but that's just,
I wouldn't be here.
You're here
if I
learning.
didn't know better.
exactly. So, and you left business school as well, so.
Well, the information systems
business and high
school,
school,
but it's
I remember.
through.
It's in the business
I
school.
was like, yeah, it's through the business school, and you got to take all the business classes. So.
You're one of the first people I've ever met that went from IS to CS.
I know, you know, it's funny because I know a bunch of people in CS that couldn't hack it, and then have gone over to
Exactly.
the
That's the
IS.
usual pattern.
And it's always once they have to take the math classes or the physics classes,
yeah.
they're done.
They're like, oh, calculus. They'll try it once or twice and fail it, and then they're saying, well, I guess I'm not a CS major anymore. Okay.
Yeah, exactly.
I'll go to
guess
business school, and then they get straight A's in business.
Oh yeah.
Yeah.
Yeah, I have a business administration degree with marketing emphasis. And
Okay.
I've worked in the bank for 20 years, and I'm ready to do something else.
Yeah.
It's sort of a natural segue if
Yeah.
I can make it work.
Now, the only thing that was, I mean, I did graduate work in business school, and it was like
You doing all right?
so easy for the most part. The only thing that was easier was the ed classes I had to take with elementary ed students.
Yeah.
I'm scared for our kids with some of the people. but-
After taking a bunch of the business classes, I understood exactly why out of 40 kids, 25 of them were like on the football team, and that's why they were in there. It was like because they couldn't pass anything else.
Well, all my peers in MBA school thought it was like the hardest thing ever, and I was like,
Oh,
I had the most fun that year of MBA school because it was so easy. I was used masters in CS. That's hard. Like that's a lot of work.
Yeah.
You know, masters in business was like a
cakewalk.
fun vacation
Yeah.
with lots of extracurricular activities. they drink a lot in business school. Like, I drank more that year when I was 27 or 8 than I ever had in my life, because this is a social thing. Like, there's all sorts of events and they all involve drinking.
Well, that and they, in the business school,
That doesn't work out very well.
I don't like them either, but
it's
if I
all
start
about
drinking, then I'm okay.
it's all about networking in the business school. It's like, you got to meet everybody. You got to go socialize with everybody.
Yeah.
No thanks. I don't like
I'm glad I'm out of that world.
Yeah.
So documenting the systems, training users, and supporting. So you have 2 audience for documentation. So, they're looking at this of the perspective of you're developing an information system and you're going to hand it off to some information systems people at the business to maintain. Like if we sell the bank software and they install it, again with the bank example, you guys have tech people that maintain that software system.
Yeah, show us how to use it.
Right. So they need documentation to allow them to keep it running, make sure it doesn't crash the servers and update all that stuff. Then there's the documentation for the people that actually use the system. So depending who you're making software for, this part, well, it was the person that kept it running. So, there wasn't as much documentation. There should have been, because then when I didn't work there anymore, good luck to them, felt bad for my employees that had to pick up those pieces, but so deliverables, system documentation, user documentation, what we just said. A user training plan, how are users going to be trained? Classes and tutorials. Like I said before about orbital shift, you'd think today's day and age that personal training and that kind of thing would be sort of diminished, but we've trained 90% of our businesses involved mostly my business partner going and hosting training sessions with employees during an employee staff meeting. Usually we'd show up. I did a lot of them too, but a lot of business is still kind of old school about some of that stuff. So, and then we did do the video tutorial thing, a ton of them. And then, like I said, we didn't have any text-based documentation, but user training modules, so training materials, computer-based aids. I mean, these are just all things that could be produced out of this. User support plan. So this is like what you were saying, the tech people that are supposed to be the first line for helping you before it goes to the company who made the software. Like, so how does that happen? Bulletin boards. And that's even a dated term, right? Like, who calls them, like, press? Totally, like, I don't know, I think I pressed page down or something and it, like, went nuts. Like, how did I jump to slide 30 from wherever the heck I was?
You're on 9.
How did I do that? Do not prompt each time. We don't call them bulletin boards much anymore, do we?
Whiteboard.
They're forums.
Over.
Forums.
Or-
BBS, that was the old school thing.
I had one.
Yeah. Forums. And a lot of people use support things, and we did this like Zendesk and different ways that are kind of a forum, but when you email it, if you emailed our support email, it would automatically get tracked in Zendesk, which would index that support request, who it came from. And you see these automated systems when you get a reply that says, your response has been received. That's a system like Zendesk that helps you track those. And then we didn't use it, but with Zendesk, you can kind of build your responses into a bulletin board, a forum, so other people can see them and comment on them. So you don't have to hopefully answer the question as many times. So maintaining an information system. So this is kind of going back to the beginning of that cycle and just repeating the steps, until the change is implemented. So you're going to get a maintenance request. or a feature request is like how our software company worked. You're going to go through that same cycle, but on a miniature version of designing, requirements, designing, going back through implementing, testing. It's just a miniature version. That's what I just said, designing, implementing, which is sort of a never-ending thing. So this diagram shows this. This inner portion is the normal cycle: planning and selection, analysis, design, implementation, and operation. But then once you hit maintenance, it's sort of just an iterative cycle that just will keep going. In a cloud environment, certainly, you have your first version, of course, has to go through this process. But we went through this process in like 3 months, and the first version was out. Then it was this for 4 years after that. So just looping around. So development of a new version of the software, new versions of design documents, training materials. This in a cloud environment is much different. And this is where it's a real pain, because what if I go into some screen and I like change one little thing? Do I shoot new training videos? Do I change if we had support documentation? Yeah, I mean, it's, if you were following this traditional model where it's a new version, like, oh, now it's Windows 10 instead of Windows 7, well, you just produce all new stuff and it comes out and it never changes that much. You know, and yeah, you know, my Office 2013, Office 2016, you just produce new materials. But when it's always changing, that's a trade-off. So talking a little bit more about application testing. So ideally, you've developed a plan for how you're going to test before you start developing. And if there's one thing I would recommend for everyone learning coding is code a little and test. Code a little and test. Code a little and test. The smaller you can break your test down, the easier. That's what a lot of beginning programmers or early in their career just think they're going to write a whole bunch of code and then test it. The less you can write, the easier it is going to be able to fix. So
Test it.
Yeah.
Make one piece.
Exactly. So, I mean, that kind of fits into this test plan. Hopefully your plan isn't to test at the end. So this is the unit test plan and a system test plan. So and they're not talking, when I'm talking about unit testing, I'm talking about more of a software engineering deal. It's where every function or method you make in your code, you specify the test cases. And then every time you build your software, all those test cases are run to ensure you specify the case and what the result should be. So if I have a method that calculates the area of a triangle, I write a unit test that passes in, here's a triangle with sides of these length, and I know what the output should be. And I have a list of those. And every time I do anything to the code, it just runs all those tests and makes sure.
Way out of bounds this way here.
Yeah, make sure you didn't break it. You know, because sometimes what happens is you make one change and it has unintended consequences. That happens all the time. So unit tests can help that, because you might have changed something way off, unrelated, and it broke this piece of code. You didn't think to test this piece of code because you're like, well, I didn't change anything over there. Unit tests can help provide coverage for that. Here, they're talking more about unit tests as like the smaller components of the software and then testing the system as a whole. Similar idea, it's just I'm talking about unit testing as the specific automated thing that you do. So kind of, yeah. Or you could just use like NUnit or some other nice modules.
That's when I never work.
So actual testing is done during implementation, of course. So as you're implementing the code, the idea though is that these test plans lay out how things are going to be communicated. Because the way it works is I would write code, and of course I would test it. I'm not going to send it to testers just saying, well, I wrote this and I never ran it a single time and I hope it works. I run and test until I think it works, and then I send it to testers to do a lot more of the system testing. Like, what did I break by this change? And a lot of times it would happen. change some query to fix some problem, and then they test them. Well, yeah, now these like random things are popping up, you know. And
When we were working on the project for databases, I was like, oh man, I can't get this one piece to work. And
yeah.
he's like, oh, here you go, and the whole rest of the
yeah,
program.
he sent me a problem and I fixed it, but I didn't look at any of the rest of it, and I broke the whole rest of his program.
That part works.
But I fixed that one part. It works. So that's the system testing part. So your test plan can make some good checklists kind of to work you through. So types of testing, inspection. So this is a good technique. So you get some people together, and this is where you do a code review, essentially is what they're talking about. And you'll look at some key areas of the code as a group, and you'll say, does this look right? Does it look like it's going to cause any problems? Put it on a projector, everyone looks at it. A walkthrough, which is kind of one layer higher, you take a group of developers and you review through the product as a group, just looking for flaws. Excuse me. Desk.
That's different than the walkthrough that they talked about when you're developing your business process proposal.
Yeah, yep. So the desk checking, this is just, you have a reviewer that manually checks through the code. Hope you don't ever have to do that job, but
It's fun.
desk checking. So unit testing, and again, they're just saying like it's a module, but you can do it programmatically to test automatically. Integration testing, so that's this kind of system. You take some of the modules that work together and you test to make sure that they work correctly. So, and like it says, typically in a top-down incremental fashion, there's no point to write some really specific piece of functionality that has no purpose without all these other things. So you start at the top and break down. System is the final thing of everything is together. Stub testing. So the idea here is you can write some modules and you just kind of put like pass statements in them that you're gonna call something else, but it doesn't exist yet, just so you can test it as a unit or as a system without the specific details. So maybe I have code to calculate the area of a triangle, but I haven't yet figured out how to calculate the area of a triangle. Hopefully that's not that complicated. And you just say like return 5 and you stub it in. So it's like you can still test it, that your interface for connecting to that and calling it works, but I haven't built the bottom part of it. So you're stubbing it in. And I do this a lot. I know the structure I want and it requires all these layers and pieces, but I don't want to write them all before I start testing it. So I put some dummy stuff in there. And then we always did .NET, so you can put these certain comments that the system will report that you need to come back and fill that in so you don't forget about it and ship the product. And no matter what someone does, the area of a triangle is 5.
Isn't the area of a triangle like 1/2 base times height?
You got it. Yep. 1/2 base times height.
About that when you're talking about.
I type in something and I can't think of the word I want, I do 3 big X's.
Yeah, it's just like that because then you can do a control F and find everywhere there's 3 X's. There's
Has,
a lot of IDEs have that same idea, but a little more advanced, you know, so.
Has Steve told you guys that story of the bad monkey story? His son was working on a project or something and they shipped it and they kept getting an error and they kept saying bad monkey, bad monkey, bad monkey, bad monkey. They put that in just as their like little error.
Yeah, they forgot to swap it out. That's funny. So in testing, you want to confirm that the system satisfies requirements. In software engineering, you talk about verification and validation. Verification is that it does what you set out for it to do. Validation is that it does that right. So verification is really this idea of verifying that it matches the requirements. I set out to develop a software to calculate the area of a triangle. Is that what I have at the end? The validation is then I test it with a bunch of known triangles and I say, is it right? So, I mean, we're talking about a 2-line piece of code I'm talking about with the area of a triangle, but a function definition and a return statement is all you would need to do that. But
$1 million program.
verification and validation.
For NASA.
Yeah. Testing must be planned. So a test case, this is like what I was talking about for unit testing. It's like a specific set of data that you're going to be able to run through and check. Now for orbital shift, we had a list of test cases, and the idea was that anytime we kind of made a major change, you would go through and test all those test cases manually. My interns who became employees would work through these scripts and spend a day going through those test cases. You can automate it with unit testing.
I'm sure it was like, hey guys, guess what? I changed something about like.
Yeah, I got a lot of grumbling. You can even do testing with some tools through user interfaces where you program it to like navigate around to different fields and type data and look at the output to the screen. I've never actually done it. You can do it. It's obviously complicated, but. So your test cases need to be specific enough that you can do the same test cases. And this bit us before we listed out test cases thoroughly enough that we'd miss things that we previously had tested, and then it wouldn't get tested the next time, and it was haphazard. I'm going to click around and create some events and move them and see what happens. You know, that's kind of how we tested in the early days, and then we came up with these test cases. Like, these are the base pieces of functionality that should work. And if you need to test to make sure that stuff works, because if it doesn't, do not deploy that. So here they have like a really specific way. We just had it like in a Google spreadsheet or something, you know, but here they're saying like, what are you testing? What's the state? What are the results? What were the actions? They're documenting every time they test it, the results. Ours was much looser. Here's what I'm supposed to test. I run it. Did it work right? If not, go walk and tell me that it didn't work right. You know, I mean, things are different depending on the scale of your business. So after you've tested internally, you verified something works, then you go into this stage called acceptance testing. So you bring in some actual users and they approve, like, yes, this is what we wanted. Now, traditionally, we go through 2 phases of this: alpha testing. So basically simulated data. It's as early in the process as you can do it. When we first had orbital shift, I'd say that was an alpha test, you know, the first users. Recovery testing, so forcing the system to fail to ensure that it performs as it's supposed to be. So do things that you know should break it and do break it, and then how does it handle that? Like make a schedule event where the start date is after the end date. Like it should catch that. And
February 29th on a year that's not.
Yeah, so things like that. Security testing. So, you know, we had a lot of this. Like if an employee logs in, they sure as heck better not be able to start moving schedule events around of themselves and other employees. That needs to be a manager. So the security of this system. Stress testing, so hammer the system and make sure it doesn't break. So especially for web, it's hard to do this because like if you're using a host like Rackspace and any cloud, do you think they're going to be happy if I start stress testing the system?
We're going to DDoS.
And a lot of those you're paying by the resource, by the computing cycle. So if you stress test it, you're paying more. So, but I mean, you want to push it to its limits. More alpha testing, so performance. So, and we would do this. There's some tools you can do in like Firebug to simulate different internet speed connections and then use the software and see how well it performs. It throttles your connection. Obviously, you can't test it on something faster than what you actually have, but test it on a 1.5 megabits per second. Hopefully not a dial-up, but
There's some people that use that.
yeah. After you leave alpha testing, you go into beta testing. Now, again, in a cloud environment, these are kind of all blurred because it's just sort of, that's why Google doesn't take the beta tag off their things for like 10 years, because then they can say, well, it's beta. We're still working on it. But beta testing is the next kind of round.
Everything Google releases a beta tag.
Yeah,
They
exactly.
don't make anything that's like.
Well, they took the tag off of like Gmail now, right? It doesn't say
well,
beta, but
it's amazing to me if like you'll go through the system of Android and there'll be like comments on it like beta release,
Yeah.
1.6.1.
it's easy to get away
It's
with
like-
that when you're giving away free software.
Yeah, exactly.
If you're having people pay for it, it's much harder. That's why Orbital Shift we gave to free to our early
was beta on
clients.
Android for years.
Yeah.
Yeah.
So ideally, beta testing is like a real working system, right? So it has real data. So installation, we got like a little less than 10 minutes. So this is changing from one system to another. 4 ways, and these were touched on at the beginning. Direct installation. So that one's you just turn off the old and you put in the new. That's hard to do in a lot of cases, right? So
Well, you're gonna move stuff over if you're.
yeah, there's data issues there. Parallel, you run the old and you run the new until management decides the old. Now, this is what almost always happened with Orbital Shift. We're not going to take the paper schedules off the wall. We're not going to completely get rid of that. We're going to do both. And sometimes that worked fine, and sometimes it didn't work at all for us because people never leave the old system and then eventually decide, why are we paying for this fancy system when people just walk in and look at the wall and see when they work? So it depends. I mean, from their perspective, maybe that was right, I guess, but there's a lot of issues with parallel. And it happened with us. Someone changes it in Orbital Shift, a manager, but doesn't print it every time they make a change. And then someone looks at the paper schedule. Oh, I don't work today. But the real system, they do. How do you keep that data in sync between both systems? It's a huge issue.
Isn't that why you did the printout, or had to write the printout stuff for it?
Yeah, it was for these parallel installations. We tried to say, don't print out. You don't need to print out your schedules. You have computers at work. People can look at their schedules, and very few people went for that. So it seemed natural to me, but it wasn't to them. So single location. So this is a pretty good way to go. Put it in one location and see how it works, and then decide it. Put it in one bank branch. Don't blow up the whole thing. Try it there, and if everyone's happy and it works, roll it out. That's how a lot of places did it for Orbital Shift. Like, we'll try it at this gas station and see how it works, and then we'll try it at our other ones. And we had that process kind of go forward. Phased. So this is the most complicated. Can certain parts be swapped out and then others? The best way, for Orbital Shift that this happened was once we had time clock. Maybe Paces tried the scheduling, but didn't commit to giving up their old time clock. And then if they were happy with the scheduling, then they gave up their old time clock and paid us for time clock. So depending on the system, how can you really break it apart, right? So depends. Here's just a comparison in diagram form. So you have the current system, you install the new, you migrate the data, the old goes away. Here's the parallel, we have both, and then hopefully eventually the old one ends. This looks exactly like this, but the idea is you try it for a longer time in one place. Well, yeah, it doesn't even, it's like the same thing. You're trying it in, this is location 2 is the idea here. You're trying it there and then you're changing. And then here's the phased, module 1, module 2. Just a visual of that. We've already touched on this. Data conversion is the big issue. Places that would do vacation requests and allow them a year out, a lot of them had paper slips. What's the conversion of getting that in the new system? Well, you go in there and you just put them in the new system. It seemed pretty simple to us, but people, you know, like so set in their ways. So that's a pretty minor issue, but you can get into a lot bigger ones. What if the old system had a bunch of bad data? Do you just merge that bad data? I mean, this is what you're seeing. You kind of got to try to fix it, but how do you fix it? Exactly. So how do you load it? I mean, there's just the practical idea. Other considerations, so planned system shut down, like when do you shut down the old? What's the process? Business cycle. So sometimes when, you know, what's their yearly cycle? What's their fiscal year? I mean, this happened with Orbital Shift. Yeah, we want to use it, but we have to wait till the new fiscal year because we've already budgeted our expenses for this year and we can't do it till the next year. So when do you install it can sometimes be dependent on those. Or time clock, you do it at the end of a pay period. You don't install it halfway into the middle of a pay period.
Because if people lose their hours.
Yeah, so
We do stuff on 3-day weekends where we come Monday holiday. Or
Yep.
Friday holiday.
school does that too, you know, like there is tons of plans for spring break, you know, so they can do a bunch of stuff that's hard to do not during spring break. So they don't get spring break, the tech people. Documentation, so system documentation. This is like the internal workings part of it. This is internal documentation. Not, I was saying internal workings of the system, but this is, you're not giving this to your end users. You're keeping it for you. So this could be comments in your source code. There are ways you can document the source code and pull that out to have kind of like doc strings. In Java has doc strings, right? You can also have some, like it's saying, compile time, some other data that you pull out. External, so this is like diagrams and anything that explains how the code works. Like class diagrams, a lot of times you'll produce those. So these are pieces that you as the company developing the software will have. User is stuff you give to your users. So the manual basically. So how do we prepare it? Traditionally, they're saying here that the source has been the information systems department of the business you're implementing it for. I mean, I don't know. That seems kind of weird to me, but that's...
Here's our product, write the manual for it.
Yeah, so usually now it's this, application-oriented documentation. It's provided by who gives it out, right? The vendor. So Orbital Shift, I wouldn't expect some IS department in a business to come up with their own documentation for it.
Did you look at it?
Though a couple did. They produced their own quick starts guides that they gave to employees that had some information. So I don't know. I'm just kind of going quick here. It's a couple minutes. Potential training topics. So the training the information system users. How do you use it? General computer concepts. The number of people I had to teach how you log into a website was a lot.
This is a mouse.
Oh, and then you get into issues of, well, I'm in pre-release and I'm not allowed to use a computer. What do I do to see my schedule? And I'm just like, I don't know. Like, look at a paper, have someone print it out for you. You know, I mean, that happened more than once. People were, you know, convicted of something where they couldn't use computers. So, I mean,
Just high school students that before they make mistakes.
Yeah.
There you go.
So here's just, I mean, you could do training topics on any of these things, any number of things. Methods, resident expert. This we did a lot in Orbital Shift. Train a manager to really know what they're doing. Then they can train the other managers and employees. Make a resident expert. Computer-aided instruction, obviously the videos and tutorials. Formal courses, so if you have a really big system, you might send employees to be trained in the system, right?
How formal, because my tuck says it's cleaners.
Yeah. Help components, so like, it pressed,
Humor.
again, I pressed the stupid thing that jumped. Let's just stop there, we're out of time anyway, so. Something, oh, it must be I'm accidentally pressing the N key. I think that's what it was. And N jumps to the last slide, because I'm just not looking at what I'm doing, so. All right, so exam Tuesday. I will talk about the rest of this at the beginning. I'm not going to pull heavily from the end of chapter 10 for the exam. But it's in the book and on the study guides. The slides are up there too, but
Homework.
and then I'll post the homework tonight.
No, and that's due Monday.
Tuesday.
Tuesday at 2:00.
Oh,
Is that doable?
Was it Tuesday? I thought it said Monday on there.
yeah, it said Monday.
It did. I decided to give you longer.
Oh, okay.
For you, it doesn't matter because you have to go to work, but I did do Monday at midnight, and then I said, well, I'll just do before class. So for some of you, that gives you a little bit more. And I know that's crushed, but we haven't done a lot of homework. I mean, I've kind of been slack on it, so we need to do
Yeah,
something.
don't worry about it. It's fine.
Yeah.
Yeah,
We'll let it slide.
I feel